All right. So in this video, we're going to look at finding empirical formulas from percent composition. And I have a little joke at the bottom. It says as easy as 1, 2, 3, 4, 5, and sometimes 6. So there are 5 steps that you have to go through in order to get this calculation down. Sometimes there's a 6th step. All right. This is by far the most step-intensive calculation we're going to look at. So here are the steps. First thing we're going to do is we're going to create a working formula. This is a formula that's going to be like, we'll say Na something Cl something. When you see those question marks, that's the working formula that we're talking about. We're working on it. We don't know what the subscripts are just yet. The second thing we're going to do is we're going to take the percentages given in our problem. We're going to convert those to grams. We're going to convert the grams to moles using our periodic table. We're going to take those mole values and we're going to plug them in as the subscripts right here and right there. And then we're going to look at the 2 subscripts or however many there are, and we're going to divide out the smallest one. We're going to divide everything, all the subscripts, by the smallest subscript. Now, sometimes that doesn't give us the magical whole number formula that we want, in which case we need to multiply out, I should say multiply, out any remaining decimals that are in the subscripts, and we'll look at all that. So here are the steps. You'll probably want to refer to this a couple times. So let's jump in and do one of these. So I'm going to slide down here to the bottom. So we have a sample is comprised of 72.4% iron and 27.6% oxygen. Find the empirical formula. All right, well, we need a working formula. We know that metals are always written before nonmetals. So we're going to say iron something, oxygen something. Okay? The second thing we need to do is convert our percents to grams. Now, this is really easy. I'm just going to change the percent sign to a gram sign. Now, the reasoning behind this, what I'm doing, I'm assuming I have a 100-gram sample. It gave me 72.4% iron and 27.6% oxygen. So if I assume my sample is 100 grams, well, that just means 72.4 grams of iron and 27.6 grams of oxygen. So 72.4 grams of iron. And we know that the next step says convert those grams to moles. Well, if I'm going to convert anything, I take the unit that I have, and it goes to the bottom. I know grams can go to moles. I know that's a 1-bracket conversion, right? There we are. And this number needs to come from the periodic table. So iron is Fe. It is 55.845. So 55.845 grams. So I'm going to take that in my calculator. 72.4 divided by 55.845. That's going to be 1.296. And of all the times that you want to have a couple more decimals, this is the time. So I'm just going to go ahead and write out a couple more. 4455. The more the better, right? And this is moles of iron. I need to do the same thing with oxygen. 27.6 grams of oxygen. We know that there are 15.999 grams of oxygen in a mole of oxygen. So 27.6 divided by 15.999 gives us 1.72. And we'll do 511. There we go. Moles of oxygen. Now, these are now the subscripts that are next to iron and oxygen in my working formula. I need to divide them, though, by the smallest subscript. So I'm going to divide both of these by the smaller. Well, the smaller one is obviously the 1.2964455. Well, that's going to give me Fe1, right? Because anything divided by itself is 1. And oxygen is going to be, the new subscript is going to be 1.72511 divided by that number there. So that number divided by that number is 1.33. All right. Now we did our 5 steps, and we have a working formula that still has a decimal in it. We're like, oh, are you kidding me? Well, let's look at that step 6. Step 6 says once you divide, and you have a 1 as a subscript, right? You can't divide out anything else. So now we're going to multiply it through. So what times anything 0.33 gives me a whole number? Well, in this case, I know that 3 does. 3 times 0.33 is 0.99, which is close enough to me to round. So that's going to give me FE3, and then 1.33 times 3 is 3.99. So we're going to say O4. That is the empirical formula that we're after. So there's a 6 step. This would be a 6 step. What's going on my pen here? 6 step, can't spell. Example. All right, right there, right off the bat. Let's do another one. Example is 60% carbon, 13.4% hydrogen, and 26.6% oxygen. Find the empirical formula. All right, well, I know I have C something, H something, O something. So we're going to go 60 grams of carbon. We're going to change that O to moles by dividing by the mass. I get that off the periodic table. They do the same thing for hydrogen, 13.4 grams of hydrogen. 1.008 grams of hydrogen is equal to 1 mole of hydrogen. That's just the molar mass, right? And we need to do oxygen, 26.6 grams of O. And we're going to say 15.999 grams of oxygen to a mole of oxygen. All right, to run our math, 60 divided by 12.011 is 4.995. 4.995 moles of carbon. 13.4 divided by 1.008 is 13.29. 294. That's moles of hydrogen. And 26.6 divided by 15.999 is 1.662. So we're going to divide by the smallest. So all 3 of those numbers, hopefully you see the smallest is 1.662. So 4.995 divided by that number gives me 3.00. So that's 3. I'm going to do the same thing with my 13.29. 1.6, it gives me 7.995, so that's going to be close enough to round to 8. Anything divided by itself is 1. Now look at there. This is a 5-step example. I didn't have to do 6 steps because when I finished my division, I had all whole numbers. So in this instance, I got things like 3.004 for carbon. And for hydrogen, I got 7.9956. And for O, obviously, I got 1. These numbers are close enough to round, right? I can round those. In this case, we're going to round them up. If you got something like 2.001, okay, that's close enough to 2 to round. If you're getting things like 0.7 or 0.6, that's not close enough to round. You'd have to multiply. So this would be a 5-step example. Let's do another one. All right, I've got manganese, which is Mn, not Mg. That's magnesium. And oxygen. I don't know what the subscripts are, but there's my working formula. I know Mn goes first because it is a metal. Oh, let's see here. Where'd my eraser go? Grams of Mn. Again, we're just going to convert it right over. I don't know manganese off the top of my head. It is 54.938. Come on, little pen. Not working. There we go. 54.9. Oh my goodness, catch up. There we go. 38 grams in 1 mole of manganese. We've got 30.4 grams of oxygen. 15.999 grams of oxygen in a mole of oxygen. Hey, there we go. All right, so we run our math. 69.6 divided by 54.938 gives us 1.26688 moles of manganese. 30.4 divided by 15.999, 1.9001 moles of O. All right, which one's smaller? 1.26688. So that's going to give me Mn1. O is going to be 1.499. All right, so that we can round to 1.5. All right, I got to do a 6 step. I got to double everything to get rid of that decimal. So that's going to give me Mn2O3. And there is my final answer. Right? So this is a 6 step. I had to take that decimal right there that I'm highlighting. Well, there we go, that I just covered up. I had to get rid of it. So 1.5 times 2 gives me a whole number of 3. And so remember, there's an unspoken 1 right there. So 1 times 2 gives me 2. All right, one more. We have 2 more left. So this one and one more. So we have carbon something, hydrogen something, oxygen something. So let's do it a little quicker. 75.69 grams of carbon, 12.011 grams in a mole of carbon. We're going to divide 75.69 divided by 12.011 gives me 6.3017 moles of carbon. 8.8 divided by 1.008 grams of hydrogen gives me 8.7301 moles of hydrogen. And we have 15.51 grams of oxygen divided by 15.999 grams of oxygen is going to give us 0.9694 moles of O. Obviously, we're going to divide by the smallest, which in this case is the number less than 1. And so we're going to have carbon 6.5. So I already know I'm going to have to do a second, or the 6th step. For hydrogen, 9.00, so it's 9. And obviously oxygen is a 1. I have 0.5 as a decimal, so I can double everything. And so C13, H18, O2. There we go. C13, H18, O2. That's our empirical formula. All right, last one. This is my favorite molecule. So if you know my favorite molecule, you already know the answer to this. But we'll go ahead and look at it. So we have carbon, hydrogen, nitrogen, and oxygen. We don't know what the subscripts are, so there's our working formula. All right. Sorry, I lost my train of thought. We'll go 49.48 grams of carbon divided by 12.011 grams of carbon, and that'll give us moles of carbon. We need 5.19 grams of hydrogen divided by 1.008 grams of hydrogen. get that one. We'll do 28.853 grams of nitrogen divided by 14.007 grams of nitrogen. And finally, we'll have 16.477 grams of oxygen divided by 15.999 grams of oxygen to get moles of oxygen. So let's run through that. 49.48 divided by 12.011 gives us 4.11956 moles of carbon. 5.19 divided by 1.008 gives us 5.1488 moles of hydrogen. 28.853 divided by 14.007, we have 2.0599 moles of nitrogen. 16.477 and 15.999 gives us 1.0299 moles of O. Our fifth step is always to divide by the smallest number. So in this case, 1.0299 is going to be the smallest number. And let's see what we get. For carbon, we have 4.00000, so 4. For nitrogen, for hydrogen, we have 4.99999, so that's going to be 5. For nitrogen, we have 2 divided by 1.02 there. 2.000. Nitrogen is 2. All right. And oxygen is 1. All right, I thought something's not right. Let me check my math. That doesn't look like me. This should be caffeine. It's a bigger molecule than that. So let's just run to our notes and see what we got going on here. Oh, no, I stand corrected. Sorry, we're doing empirical, not molecular formula. So that is the empirical formula of caffeine. It's not actually the molecular formula. I am so sorry. All right, so that is the last one that we're going to work. If you have any questions, please let me know. We'll be doing molecular formulas in the next video. I was getting a little ahead of myself there. So there is our empirical formula for caffeine. Obviously, that's not really caffeine. Anyway, if you have any questions, let me know, and I will certainly be glad to give you a hand.